Alright, we have looked at quadratic inequalities in terms of two variables, in terms of one variable. We have looked at them graphing. We have looked at graphing and shading on a number line. Today we are going to look at quadratic inequalities in one variable, shading on a number line. So we were shading on a graph. Now we're going to take that idea and put it on a number line. So it's really not a lot different from what we did previously. So in the warm-up, it says a water balloon is launched from a slingshot, can be represented by several different quadratic equations and inequalities. First, suppose the height of the water balloon, h of t, in meters above the ground, t seconds after being launched, is modeled by the function negative 4.9t squared plus 32t plus 1.2. You can solve a quadratic inequality to determine how long the balloon will be in the air and at what height it will be in. In what ways can I model this situation? So we can model the situation in a couple different ways. The most obvious way to model any quadratic situation is by graphing. So one of the best ways to model a quadratic situation involving an object's path is graphing. We could also model it by transforming its equation. To see the vertex. By knowing the vertex, we will know the maximum height that the water balloon reached. We will know when the water balloon is halfway through its path. And by knowing when the water balloon is halfway through the path, we can double that time in order to find when the water balloon hits the ground. Which way does the parabola for the given quadratic function open? How do you know? Well, the quadratic function is going to open down. I know this because the a value is negative. Which tells me the graph is reflected. And then the follow-up questions to that is, at what time will a water balloon be within 3 meters of the ground after it has been launched? So that is asking me to find when h of t equals 3. So in order to do that, you take the function given to you, and set it equal to 3. And then we know that in order to solve a quadratic, we can use the quadratic formula. But in order to use the quadratic formula, my equation has to be set equal to 0. So in order to do the quadratic formula for this, we have to subtract 3 from both sides. And then we can plug into our quadratic formula. So that's negative b plus or minus the square root b squared minus 4 times a times c all over 2a. So 32 squared minus 4 times negative 4.9 times negative 1.8 is going to remain a negative because negative times a negative is a negative. So you get 988.72. The square root of that is about 31.44. So negative 32 plus 31.4439 divided by negative 2 times 4.9 or 9.8 gives 1 time of 0.056 seconds. And you could have said 0.057 as well. And a second time, so that was the negative 32 plus, so we're going to do negative 32 minus 31.4439 divided by negative 2 times 4.9. And we get the second time is at 6.473 seconds. So that should make sense. The initial height of the object is 1.2 meters. So then if the object is launched up in the air, it is going to cross through a height of 3 meters twice. Because again, here's kind of the idea of your function. Initial at 1.2, going up to a height of 3. It's going to go up and then come back down until it hits the ground. So that means that it's going to hit a height of 3 twice. And that first time is that 0.056, and the second time is 6.475. So what that tells me is that I know the object is hitting the ground after 6.475 seconds. So don't tell me that object hits the ground sooner than that. So let's keep going. Yes. And we have graph the original function on your graphing calculator. Then graph the new equation found in part 3. How did they compare? So we can take out our graphing calculators. And I want you to put in both of those equations. One where your y-intercept is 1.2 and one where your y-intercept is negative 1.8. So again, you want to get your equation in y1 and y2. One where your y-intercept is 1.2 and one where it's negative 1.8. Knowing what we know, what should I know about the equation in y2? Well, without even hitting graph, I know that this equation is going to hit the x-axis twice at 0.05 and 6.45. I would anticipate this graph is lower than that graph because the y-intercept is less. So I would anticipate the second equation is below the first equation. So there's the first in blue. There's my second in red. Let's change our window to kind of see that better. So again, it's hard to see, but you can tell that the red is below the blue. So how do they compare? They compare because the second graph is below the first graph. And then what did the zeros of the new equation tell you about the water balloon? They told me when the water balloon was at a height of 3. So again, we are going to look at graphing quadratics throughout this week still. We're going to be doing more on our graphing calculators as we work through the next couple of days. So we're really focusing on graphing inequalities as well as being able to use our calculators and find quadratic equations given data. In example 1, the height of a model rocket in feet seconds after its launch can be represented by the function given below. During what time interval is the rocket at least 100 feet above the ground? So this one is a little different because now I want to know the time interval in which the rocket is at least 100 feet above the ground. So not equal to 100 feet above the ground, but at least 100 feet above the ground. So I want to know, when is this function greater than or equal to 100? Because that will give me the times at which my rocket is above 100 feet. So we're going to subtract 100 over to the other side so that we can find our function zeros. So by moving over 100, I can solve using quadratic formula to find my roots. And then I can determine the interval in which the roots are either going to be positive or negative. Since I want it to be greater than or equal to 0, I am looking for the positive values. This is not something we can factor, so we'll use quadratic formula. So it's negative b plus or minus the square root of b squared minus 4ac C all over 2A So your discriminant value was 340. So you should get 82 plus or minus the square root of 340 all over negative 32. And then that's going to give you your two answers. You get 82 plus the square root of 340 divided by negative 32. Sorry, my 82 should have been negative. Sorry about that. When I wrote it here, I don't think my negative went through. So when I put it in my equation, it should be negative. Making that a positive 1.98 and a positive 3.3. So in order to determine when it is greater than or equal to 100, we need to know when this equation here is greater than or equal to 0. So we know that our time can't be less than 0. And then we want to know, okay, what's happening to my time between 0 and 1.986? And what's happening to my time between 1.986 and 3.138? And what's happening to my time from 3.138 and beyond. Now, looking at this equation and knowing that it's going to go up and then come back down, my anticipation that it is greater than 100 will occur between those two given times. But we want to show that algebraically by simply plugging in a number. So you're going to take the number 1 and plug it into this equation right here. So that's negative 16 times 1 squared plus 82 times 1 minus 99.75. And we see that that is negative. And since we're looking for my inequality to be positive, we know that that's not part of our roots. So then we go and we plug in the number 2, because that's between 1.986 and 3.138. So you get negative 16. Now we're multiplying by 2 squared. And then we're adding 82 times 2 and subtracting 99.75. And we get 0.25, which is positive, which is greater than or equal to 0, which means that from 1.986 to 3.138 is part of my interval solution, because the graph will be greater than or equal to 100. And you should always confirm that you plug in 4, and it is also negative before you it from your solutions, and you get negative 2.75. So that is negative. So the interval with which my rocket is at least 100 feet is 1.986 to 3.138. If you write it in bracket notation, then it is a bracket and not a parenthesis because it includes the endpoint. So it is a bracket and not a parenthesis. It is closed circles at those endpoints if you graph it on a number line. Okay. So again, we are solving algebraically a quadratic inequality. This time we have x squared minus 3x less than or equal to 18. So you're going to subtract 18 from both sides, making your quadratic inequality less than or equal to 0, which means we are looking for the roots that are negative. You can always use quadratic formula, but if you recognize that a function is factorable, you can also factor it. So in the case of this problem here, we know that this can factor because the factors of negative 18 that sum to negative 3 are going to be negative 6 and positive 3. So that means that my roots are at negative 3 and positive 6. This graph would kind of look like a quadratic. It's open up. So what that means that this quadratic is open up, so it would sort of look like that. So my solutions are either going to be between or outside those 2 points. So you can test point. We are looking for our solutions to be negative. So I always start with 0. So 0 squared minus 3 times 0 minus 18 gives a negative 18. And negative 18 is in fact less than or equal to 0. So that means that this gets closed points on my endpoints because it's equal to. And your solutions lie between your roots. You can always check the outsides if you want to. So you could plug in 7 or negative 4. But if you plug in 7, you're going to get a positive. And if you plug in negative 4, you're also going to get a positive. So those are beyond or above. So all my solutions are coming from below. Does that make sense? Bless you. So in bracket notation, that would be negative 3 to 6. In interval notation, that would be negative 3 less than or equal to x less than or equal to 6. And on a number line, it's closed circles shade between. So all three of these are ways to represent the solutions. They all mean the same. Okay, so once again, we're going to get my inequality with a 0. So this time we add 6 to both sides, making it less than 0. So once again, we're looking for the negatives. This quadratic is also factorable. So you have x squared plus 5x plus 6, which means that your roots should be at -2 and -3. So that means this factors as x plus 2, x plus 3. So my solution set is either going to be inside or outside. It is not going to include the roots. They're going to be open circles, which means my answer was going to have parentheses, not brackets. So we could test point outside by picking 0. So 0 plus 5 times 0 is 0. 0 plus 6 is positive. So since 0 is positive, I would anticipate my solutions are going to be between. To do between, you'd have to do something like -2.5. And if you plug in -2.5, you get -0.25. So that is negative, which is less than, which means my solution is between -3 and -2, or less than -2, but greater than -3, not including. You could also test point something like -4 or 5, and we see that that is also positive. And we want the negative because that's less than 0, and values less than 0 are negative. That's why we're picking the negative. It makes the inequality true. Okay, and example 3, you have x squared plus 11x plus 30. So once again, you are looking at, okay, can I factor this? Yes, I can. My roots are going to be -5 and -6 because x plus 5 times x plus 6 is greater than or equal to 0. Now I'm looking for the positive parts. Once again, these roots are closed circles at those points because now my inequality is greater than or equal to, and you test point around it. So when it's -7, -7 plus 5 is negative. -7 plus 6 is negative. A negative times a negative is a positive. Therefore, -7 is positive. Plugging in 0, 0 plus 5 is 5. That's positive. 0 plus 6 is 6. That's positive. Two positives make a positive. Plugging in -5.5, that gives you a negative here. Plugging in -5.5 here gives you a positive. So a negative times a positive is a negative. So it is positive below or to the left of -6 and to the right of 5. Which means my solutions are -infinity to -6, including -6, and +5 to infinity. Okay, so you are finishing your packet. Don't worry about the textbook homework. We're just finishing the packet. Tomorrow, if you have your own graphing calculator, make sure to bring it. And if it needs charge, try to have it charged.
I tore my packet, my actual packet.
Like, you want tape or a stapler?
I'm good. It didn't tear all the way.
Okay.